Hello everyone, welcome to Route 53 Part 1. In this topic, we'll be discussing Route 53, which is AWS's DNS offering. This is our agenda for pre-Route 53 talk. We'll discuss domain name system, then how DNS hierarchy looks like. We'll discuss how to get a website to internet, and finally, we'll close with some DNS literature. Domain name system. We use domain names almost daily. When you type www.google.com, you are using Google's domain name. When you typed udemy.com to come to this session, you used Udemy's domain name to come to this page. Domain names are mapped with IP addresses of servers where actually the contents are placed. Let's see that in a little bit more detail. Let's take example of www.amazon.com. Amazon.com is Amazon's domain name. .com is called the top level domain and Amazon is actually the domain name. The purpose of domain name system is to map these domain names to IP addresses. See, whatever you see on internet, be in Amazon Retail, Google, Udemy, etc., all contents of those websites are hosted on physical servers. And we denote servers uniquely using IP addresses. It's very difficult to remember IP addresses for human beings. If you're creating a product and hosting that on a server, you would not ask your clients to use the IP addresses to get to the product page. You'll give it a proper name and somehow you'll map that name with the IP address. This is where domain name system plays its role. You will provide this name to your clients. Nevertheless, you can find out the IP address for a domain name using a command which you have already used, that is NSLOOKUP. Let's try to find out the IP address of the server where Google's main page is hosted. If you type google.com in your address bar and press enter, it will take you to google.com's main page. As I'm in India, it has taken me to google.co.in. So we get this page and there are a few things here. Now where this page is being hosted, of course there has to be a server which of course would be having an IP address where this page is being hosted. How do we find the IP address of that particular page? We use NSLOOKUP command. Type NSLOOKUP and then the domain name of your website, press enter, it will give you the IP address. So the IP address here is 172.217.163.35. So let's use this IP address and see what do we get. We are in a blank page. If I type the IP address or paste the IP address in the address bar and press enter, it takes me to Google's India's website. That means this website is actually being hosted on that particular IP address or that particular server. How do all these work? Let's take a dig. This is my computer at home and I type www.google.com in my internet browser. There is my internet service provider which works as a DNS resolver. That means my internet service provider will help me get the IP address corresponding to the URL which I have pasted in my browser, google.com. So request to get the web page for google.com would be forwarded from my machine to my ISP and it will start its work. First, it will connect to something called root server. It will ask root server, I have a domain name, google.com. Do you happen to know the IP address tied to this? Root server would say, well, I cannot give you the IP address, but it seems like it belongs to .com top level domain. I know the place where information about .com top level domain would be available. I can give you that. So root servers keep information about TLD servers or top level domain servers. So ISP will go and get the IP address of the TLD server from here. After that, it will connect to the TLD server or top level domain server for .com. TLD servers keep information about something called authoritative name servers. Authoritative name servers are the ones which will have the actual mapping between domain name and IP address. ISP DNS resolver will ask this TLD server the same question. Do you have IP address of google.com? TLD server would say, although you have come to the right place, I do not have the exact mapping, but I know the place which has it. That means TLD server would have IP address of the server that has this mapping information. So ISP will get this information and hit the final leak. This time DNS resolver would go to the correct place which keeps the actual mapping and it is called the DNS server. This contains IP address or individual domain names. DNS server is also called name server. In the command nslookup, which you have been using to get IP address for a domain, ns stands for name server. So nslookup is actually name server lookup. DNS resolver will get the final information it needs and return that information, which is actually the IP address of google.com, to the browser. And then browser will hit the IP address directly. All these happen in a fraction of a second. But this is, in a nutshell, how the entire domain name system works, more or less. Without DNS, none of the websites or URLs would have behaved the way it does now. This mapping of domain name and IP address would be saved temporarily with the DNS resolver, which is actually our ISP or internet service provider. So that if next time someone types google.com again, it does not have to take all these steps. This temporary time is called time to live or TTL and is configured in the DNS system. So time to live is set up here, and when it is sent to ISP or the DNS resolver will keep that time or temporary time in mind and will save that particular mapping of domain name and IP address for that period of time. In the previous slide, you must have seen the hierarchy of travel for the entire journey. First, ISP's DNS resolver, then root server, then TLD server, and finally to the name server, which contains the mapping of domain name and IP address. So, root servers are at the top of the hierarchy. Every request for websites or domains go through the root servers. Notice I said root servers, plural. There are hundreds or thousands of root servers around the globe. The next in the hierarchy is TLDs or top level domain servers. .com, .edu, .org, .gov.in, .gov.us, .co.in, all these are top level domains. Then we have actual domains, which contain the mapping between domain names and IP addresses. We can also have sub-TLDs like .gov.in is for Indian government, .gov.us is for US government, and so on. So sub-TLDs are nothing but sub-top level domain names. Let's discuss how to create a website and put it on internet. First step is to start up a server or host where your web server will run. Say IP address of the server is 10.20.30.40. This is similar to when we created a basic web page in orange background in our EC2 instance. This is your server and you will design and code your web page here. Step 2 would be to get a domain name from domain name providers like GoDaddy, Phenom, or name.com, etc. etc. We'll be using Phenom.com to get a free domain name for ourselves. GoDaddy, name.com are some famous domain name providers. We'll use that domain name to connect to our web page. Then the final step is to link this domain name with IP address from step 1 using DNS system or domain name service. This is our final step, as I said. Once this is done, we'll have our website available over internet. Once step 3 is done, this link will go via domain name system. Browser will get IP address of our server using algorithm shown earlier and then connect to the actual server. This red place would actually contain the mapping between domain name and IP address, which is actually the DNS system. Now we'll talk about some DNS literature which are very important when you start working on Route53. Authoritative name server. It is a server component in domain name system which holds actual DNS records like ANAME, CNAME, Alias, etc. It contains the actual mapping, as I said earlier, mapping between your domain name and IP address. ANAME record actually maps your domain name, the front-end domain name with back-end IP addresses. A is for address. ANAME is for IPv4 addresses only. There is one more similar record type which is called AAA name record, and that is for IPv6 addresses. This is how ANAME record would look like. First A record says, or ANAME record says, that abc.com is hosted on the IP address 101.202.30.40. Similar is the case with second one, www.apple-orange.com is hosted on an IP address which is this. The third record is actually the AAA record, and it maps a domain name www.example.com with this IPv6 address. We have one more column which is TTL or time to live. Earlier we saw how DNS resolver setting our internet service provider facilitates us to get the IP address for a domain name. TTL says for how long the mapping would be saved in DNS resolver's cache. For the first record, it will be saved only for a minute. In the third case, it will be saved for 10 minutes. Typically, when you configure TTL for real-life scenarios, there will be much more than these settings. A few more DNS literature. We have something called canonical name or CNAME record, which maps one domain name with another domain name instead of an IP address. It is something like this. Your actual domain is appleorange.com, which maps to this IP address. But you decide to have another domain name for your website. In this case, you can use CNAME records to map additional domain names to the same server or IP address. You cannot create a CNAME record at zone apex. Zone apex is the domain name which is mapped to your IP address. In this case, www.apple-orange.com is our zone apex. Then we have Alias. Alias name is similar to CNAME record with a little difference. The difference is that you can create Alias record at zone apex. We'll see this during our Route53 demo. This brings a question how CNAME record would work with so many domain names. This is my machine and this is the name server for my domain. When I try to get the IP address of vegetables.com, it will search this name server and return fruits.com because for vegetables.com we have CNAME record, not A or AAA record. So DNS resolver will go again and try to get the IP address of our fruits.com. But DNS name server would return appleorange.com this time. DNS resolver will again send appleorange.com and this time the IP address would be returned and browser from my machine would be able to connect to the actual server. Notice something here. Because I tried vegetables.com as the domain name, a lot of trip had to be taken to get the actual IP address. This is also called URL redirection. And this is definitely not a good thing because your latency would increase. I have talked about latency a few times throughout this course. Let's see what this is. Network latency is the amount of time taken to deliver some amount of data over internet. We have source and destination machines here, machines, servers, computers, whatever you might want to say. This is the network pipe through which data is transferred. And I want to transfer this piece of data from here to here over the network. Let's say it took 10 seconds for the entire process. Also, I want to know whether the delivery was successful or not. So the completion message travels over the network again to inform me at the source. Let's say this process took 5 seconds. In this case, we would say that the latency was 15 seconds. If the size of the data was say 900 megabytes, then bandwidth would be the total amount of data transferred per second. That is 900 megabytes transferred over 15 seconds. So our bandwidth would be 900 by 15, which is 60 megabytes per second. That's all I want to discuss in pre-Route53 talk. Before ending this topic, let me go ahead and register a domain name. I'll use freenom.com to get my free domain name. You can try anyone you like, but I would suggest you get something which is free. We'll use this domain name for all our Route53 demo. Go to freenom.com. You can find your free domain here, but before that you'll have to register. I have already registered. So this is my free name main page. I do not have any subscription. Once your registration is done, you can go ahead and search the domain which you want. Go to freenom.com again and type the domain name. So we'll use AWS-Foundation. That is the domain name we are looking for. Click on check availability and it's showing aws-foundation.tk is free. .ml, .ga, .cf, these are free. If you search for aws-foundation.com, aws-foundation.com is available, but you'll have to pay some price for 1 year. But instead of that, as it is demo, we can use the free domain name, which is aws-foundation.tk. Click on checkout. Remember to remove the .com domain as I just did, because that will cost you some money. For how long you want it to be free? I'll take it only for 1 month as of now. The maximum free you can get is 12 months. So if you need more than 1 year, then it will be chargeable. Click on continue and then place complete order. That's it. You have got the domain name. This is my order number. You can go to your client area and click on services, go to my domains. You'll see aws-foundation.tk. You can use your own domain name. Do not use aws-foundation. If you want to use this domain name, please append it with your name. So your name -aws-foundation.tk. Then you can use that domain name. Going forward, in all our Route 53 demo, we'll use this domain name, aws-foundation.tk. That's all for pre-Route 53 talk.